Hello, hello, hello. Hello, hello, hello. Hello, hello, hello. Are you all able to hear? Heath, are you all able to hear? Hello. Hello, everyone. Okay. Screen is not viewed, no? Okay, 1 second. Are you all able to hear, students? The voice is proper? Hello. Heath, is the voice proper? You're all able to hear? Yes, no in the chat section. Yes, no. Do say yes or no in the chat section. Come on, come on, come on. Where are the others? Hello, hello. Hello. Are you able to hear, Heath? What about others? They haven't joined. Hello. Come on, come on. Hi, Karthik. Heath, not audible. Okay, not audible. Why? Hello, hello. Voice is going not audible. Hello, hello. Are you all able to hear? Is it audible? Hello, hello. Audible, audible. Okay, okay. Proper. Audible, students? Upper. Where is Vimal? Join fast. What about others? How is it going? Okay. So will we start? 1 or 2 minutes will wait. Today we'll be starting the physics chapter. Electric charges and fields. Where is Vimal, Akash, Keshav? Come on, fast students. It's a bit late night, a bit difficult for all of you. By 18th, I think so, second PO, everything, exams and everything will be over. So timings will be a bit more, what do you say, proper. By 8 only we'll start and by 11 we'll finish. Okay. So then let's start the session. Okay. Do inform the others, okay, who are there. Session has started. Okay. Just once I'll check. Chalo, let's see. Yeah, Karthike will be giving you fixed timings. Okay. By today or today, no, tomorrow max, you'll be having a proper fixed schedule so that you don't have any difficulty. Okay. Don't worry. 1, 2 things like will be just taking care. After that, it's will be static timing, no change. Not even a single minute will be changing. Okay. So tomorrow, whatever happens, sharp 10, everybody tomorrow sharp 10 will be starting for maths class. Okay. Okay then. So we already know about the analysis. This chapter holds a very good weightage, and that is minimum 3, 3, 3, 2, 2, 5, 3. So you can expect a question of 3 marker, 3 questions, or 2 if the luck is bad, or 5 if the luck is good. And the questions are very simple, not very difficult. The questions are very simple. Okay. So this is one thing. So then let's see the subject. Let's see what is there in this chapter. Okay. So we'll start now, or do you want me to wait for one more minute? 10:10 will start, or will we start now? Do put in the chat section. Whoever wants to join, do join fast. Come on, come on. Okay, then let's start now. Without any further delay, let's start the chapter. Anyway, it will be recorded and kept here, so you'll be able to watch it. So no issues. We're starting the chapter electric charges and fields. Electric charges and fields. Very simple chapter. So let's see what we do in this chapter. Is there a delay between the what is shown in the screen and what I am telling, and how much is the lag? Can you all tell me? Is there a delay, or like it is okay? Okay, I don't know, but okay, let's see. Now, the first thing is electrostatics, okay, or electrostatistics. What is it? Half a minute delay. Okay, 30 seconds. Okay. So electrostats means what? Here we'll be talking about charges which are at rest. Okay. Electrostats means what? Talking about the charges which are at rest, means not moving. Simple. Okay. Charge, intrinsic property of the matter. Okay, it's a property of the matter. It is independent of the quantity of matter. Doesn't matter, like if it's a 1 kilo substance or a 2 kilo, it can have small charge also, it can have big. It doesn't mean a bigger mass is there, bigger object is there, so it should contain a huge charge. Illa, nothing like that. Clear? So it's independent of the quantity of matter. Independent of what? Quantity of matter. A small quantity can also hold a huge amount of charge. Clear? Next, what's the symbol? Q. SI unit, Coulomb, very important. And what are the different types of charge we have? One the positive charge like proton, one the negative charge like electron. Clear? So first page, clear, very simple, easy to understand, students. Any doubt, anything slightest, do tell it. Okay? Clear, clear. If no doubt, just put ND. Okay? Just 1 second. Now let's see. Now coming to the dimensional formula. Welcome. Now till here we got it. Heat will come to the dimensional formula also. Now, so we know charge is a scalar quantity, not a vector. You'll say, sir, why? Because if you put a charge, it can have all directions also. We'll see. We'll come to that. If two same charges are there, then what will happen? They'll repel. If opposite charge, they'll attract. We all know this much. Very simple. Correct. If you bring two same charge, they'll repel each other. And if two opposite charges brought, they'll attract each other. Clear. Charge on one electron. If you take one electron, what is the charge on that electron? 1.6 into 10 power minus 19 coulomb. 1.6 into 10 power minus 19 coulomb. Okay. Now, charges have additive nature. Let's say one body has 1 coulomb charge, other body has 2 coulomb of charge. If I want to know what is the total charge, I can add it. Okay, I can add. If one body has minus 1 coulomb of charge, other body has plus 2 coulomb of charge, I can also add it. Simple. Clear? Like here 9 coulomb charge minus 3 plus 20 minus 100. So if I want to know what is the total charge, I can just simply add the charges. So charges have additive nature. Clear till here? Clear till here? Next, quantization of charge. Very important, quantization of charge. For this also you will be able to solve 2 to 3 questions of PYQ from the Kcet and Comedk part. Just by knowing quantization of charge. Just by knowing quantization of charge. Now what does quantization of charge says? It says that the charge always comes in integral multiples of E. Means they always come in number of integer multiples of electrons. Like you can have 10 electrons, 20 electrons, 30 electrons like that. You can't have half electron charge. Clear? So what quantization of charge says that the charge on any body is integral multiple of E. Is integral multiple of means in integer numbers you will get the charge. Integral number of electrons you will get the charge. Clear? Got it till here, everybody? Clear? Okay. So quantization of charge tells us that the charge on any body, okay, like let's say this body, how much charge can be? It can be 10 electrons, it can be 20 electrons, okay, it can be minus of 20 electrons, but it can't be like half of electron. It always has to be integer multiple of E. It always has to be integer multiple of E. Okay. Now, one of our heat asked what is the dimensional formula of charge. I didn't say that time, okay, because see, charge if you are defining, if I'll go for the current part, directly we don't come up. Dimensional formula for charge will go like this. Current is equal to what? Students in the current chapter will read charge by time. Here we know the dimension of this, we know the dimension of time. Can we get the dimension of charge? Easily. Clear everyone? Charge is equal to current is equal to what? Charge by time, amount of charge flowing per unit time. So Q is equal to what? IT. We know the dimension of current, we know the dimension of time. Can we find the dimensional formula of charge? Yes or no? Clear? Can we find the dimensional formula of charge? Yes or no? Correct. What is the dimension of current? Anybody? Heath, Karthike, what is the dimension of current? Come on, come on. Very simple question I've asked. Okay, okay. Okay. So, Coulomb T inverse, Karthike wrote. Okay. You converted in Coulomb only. Okay. See, current is equal to charge by time, Q by T. Current we can put ampere. A lot of times I also we can denote. So, charge is equal to what? Q is equal to IT. So, it is either ampere time or you can write IT also. A lot of places they'll tell which formula you are using. You have problems in dimensional formula, no issues. When we'll do that, when we'll complete that chapter, you'll be done. Very simple, very easy. We'll take like max 1 hour session for dimensional formula in between and it will be done. Okay, clear? So as of now, just keep it for any question what they're asking. I is equal to what? Current is equal to what? Charge by time. So if I want to find the dimension of charge, what I'll do? This dimension of current into dimension of time. They'll tell you what they're taking in the question only. Either they'll use I as I only or they can use as ampere also. Okay, whichever options we get both also. Okay, and time we can know. So sometimes it is written, you'll get options like IT also. Sometimes you get ampere seconds also. Okay. So basically you will get in the time of IT most. Okay. Yeah. Now let's see. Now one simple question to everybody. One simple question, don't cheat it. Calculate the number of electrons in 1 Coulomb charge. Kcet question. Okay. It came in CET previous years. What is the number of electrons? It is a CBSE question also. NCERT question also. What is the number of electrons in 1 Coulomb charge? Can you find it out fast, fast, everybody? I need answers from everybody. Come on, fast. A very simple question I've asked. No complex, nothing. And I've shown the answer also. So no cheating and honestly do it. If anybody still has difficulty, I'll show. No issues. What about others? Be active in the chat section. Do write yes, no, yes, no. So I'll get to know yes, you are understanding, not understanding. Okay. So first answer we got 1.6 into 10 power 9 power 19 electrons. Okay, what about others? Minus 19. Okay. I think so. That is the charge on 1 electron. We are asking the number of electrons in 1 Coulomb charge. Think a bit. Think. Nobody. Come on, come on. Where is Lucky? Karthik? Where is Lucky? पीयूष प्रैक्टिस शीट्स फॉर कहाँ पर मिलेंगे Comedk के लिए प्रैक्टिस शीट्स ऑलरेडी इन्फॉर्म नो पीयूष in the app only you'll get it. I'll send you the screenshots. Okay, Wimble, after a long time, where were you, kid? Huh? You got delayed, Wimble. Very soon I'll fix the timings and no delay, students. Okay, we just have what? Not 30 days, also 25, 26 days. Okay, I want everybody on proper timing. Once by tomorrow or day after the timings will fixed, Don't be delayed. If you haven't eaten anything, start the class. What do you say? Wherever you are, just class is very, very, very important. Okay. Heat, what happened first time, why you got wrong? See, we already know, sir, Q is equal to what? Ne. Now here charge is 1 coulomb. So 1 is equal to what? N number of electrons into charge of 1 electron, charge in 1 electron. Now send it that side. So N equal to 1 by 1.6 into 10 power minus 19. Now this minus you put it up. So what you'll get? 10 power 19 divided by 1.6. Now solve it. So you'll get the answer 6.25 into 10 power at 18 electrons. Clear? Oh, you're studying Hindi. Okay. Hindi is chill only, no? Simple. Correct. 18th you have Hindi exam, no? Okay. Till Hindi exam, I'm giving you the relaxation. After Hindi, no relaxation, Vimal. Okay. Do best in Hindi also. Because we need out of out as good marks. Okay. No, we're not asking energy. I said number of energy. We don't ask no heat. Very rare you will see number of energy. Quantity of energy will be how much energy. Number they won't ask. No. Clear? Okay. No issues, no issues. Chalo, let's see the next question, next page. Difference between charge and mass. Very simple. Did not. What happened? He did not or did not read the questions properly. Okay. Charge always comes with mass, but is it necessary that mass will have a charge? Think about it at home and do tell me the answer tomorrow. Okay. Now, coming to this point. Charge we can have positive, negative, neutral, mass always positive. Charge independent of the velocity of body. How fast also you're moving doesn't matter. Mass, it matters. We have one formula as of now. Later I'll explain this. Don't worry. I'll put up a proper animation kind and I'll explain. Very simple, very good. Okay. We'll talk about theory of relativity also. As of now, not needed. Okay. Charge always conserved, mass not. Why? Because whenever we do energy conversion, mass sometimes gets converted into energy and gets lost also. Force between charges can be attractive or repulsive, but two bodies, if they have mass, always attractive. Two bodies, if they have the mass, they are always attractive. Any doubt, kids, in this part? Very simple, very easy. This much, whatever the concepts I'm giving, will be more and more than enough for CT. Clear, everyone? Any doubt? Yes, no, and in the chat section. Yeah, Piyush will be putting up that in the test series option where we'll be launching by 20th a test series option where per chapter 10 to 15 questions will also be there. It takes a bit time. We can't just put any question and say to the student, yeah, this is the important questions or like this kind of question will come. So it will take a time, Piyush. By 20th, you can expect that part to be ready. Okay, we are working on that. It will take a bit time. Okay. Now, let's see students. Next, conservation of charge. Charge conservation is very simple. You can neither create nor destroy. So it means it is just changing from one form to another. Clear? Somewhere it is lost, so somewhere it is gained. If I can't create anything or I can't destroy anything, so what will happen? It will just change form. Clear? Next, we'll talk about our brother, okay, the Coulomb's bro. Now, Coulomb's law, very simple. What he said, two charges are there. Okay. How much price will be of the test series? Price of the test series will be For the students enrolled in the course will be none. For the students, those who have not enrolled, I think so around 299 rupees will be there. Okay, with the discount it will be 299 rupees, nothing more than that. Okay. Now, let's see here. So we have one charge Q1, we have another charge Q2. Okay. As of now, I've taken both positive. So what will happen? This charge will, what I said, two positive are there, both same charges. What they'll do? They'll push each other. So the first charge will apply a force this side. Okay. And the second charge will apply a force this side, pushing it this side. Clear? So the force is acting along the line joining, and the force is acting what? Along the line joining these two charges, correct? And the magnitude of the force we can find by using this formula. Force is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, where R is the distance between these two charges. Clear everyone? Very simple. Coulomb's law, very similar to gravitation's law also. Clear? Newton's law of gravitation, there also is very simple. F is equal to G m1 m2 by R square. Their mass is there, air charge is there. So what we are seeing, Coulomb's law states that, very simple, two charges are there. If two charges are there, then what they'll do, if they're same charges, they'll repel each other by a force how much? Given by Coulomb's law. If they're opposite charges, they'll attract each other by how much force? Again given by Coulomb's law. And we can use this formula to find the magnitude of that force. Clear? And for direction, what we'll do? For direction, what we'll do? We'll see. If both are positive, they'll repel. Outward force. If both are, one is positive, one is negative, inward force. Clear everyone? Very simple concepts. In simple way we'll go through without having much difficulty, okay? Clear? Akhilesh didn't come up, Lucky didn't come up, and other kids are also there. Once exam is over by 18th for all the students, we'll be going in a much rigorous pace. Okay, we'll be going more stronger. And you'll have an idea how I'm teaching, what is the difficulty, what is plus minus. So you can inform me, sir, this part we need more fast or more slow, whatever it is. Okay. Next, everybody clear till here? Clear. Hi Nishant. Hi Nishat. Okay, hi Nishat, sorry for that. Okay, clear, good. Next. Now, we want to know what is this value of 1 by 4 pi epsilon naught. Because in exam we need to use, in Kcet and Comedk exam we need to use this formula. So 1 by 4 pi epsilon naught, this whole value is nothing but 9 into 10 power 9 Newton meter square per Coulomb square. Newton meter square per Coulomb square. Can anybody tell me how did we get this unit? Can anybody show that he can get this unit? Find the unit of K. F is equal to what? K Q1 Q2 by R square. Find the unit of K. Fast, students. Come on, come on, come on. Let's see. Hi Akhilesh. It took a lot of time, bro. You were there or you were not there? And whoever comes in the, what do you say, this one, live session, do put up, hi sir, something. I'll get to know, okay, this kid is studying, this kid is not studying, okay. Any difficulty, any doubt, put it up, okay. Now, I gave a very simple question to you all. What is that? I want you all to find the unit of K. We know formula F is equal to K Q1 Q2 by R square. Can you find me the unit of K? Let's see who can do it. Somebody said he's not good with units and measurements. I'll show. Okay, Karthike, you show. Good. R square, Q square. Okay. See, you need to put a bit unit Karthike. What do you do? What is the unit of force? Sir, force unit Newton. K unit I don't know, sir. Uh, Charge unit Coulomb. Again one more charge Coulomb. And for radius it's in meter length. Okay, so meter square, sir. Clear? So K is equal to Newton, send the meter that side, meter square, and Coulomb will be going down per Coulomb square. That's it, sir. Clear? So K unit is Newton meter square per Coulomb square. I think so everybody got it, correct? But the way of representation was not proper, but okay. Clear everyone? Now correct, Vimal. Newton meter square per Coulomb square. Very good. Got it, Nishat? If doubt, I'll again explain. Anybody has any doubt? H. What does H stands for, Karthik? Sony got it. Okay. Yes, sir. Okay. So if you have no doubt, just put ND. We'll get it. Okay. Good. So everybody good to go? Let's erase this part. We'll come more in details. Okay. Now, next, what is the value of just epsilon naught? See, in J and all papers, they'll give the value, but in CT sometimes they don't, and not always it is written. So you should know it also. Epsilon is 8.854 into 10 power minus 12. 8.854 into 10 power minus 12. And the unit is what? Just inverse of K. Unit is what? See here, these two doesn't have any unit. So 1 by epsilon naught, if I talk about the unit, is equal to K unit. So if I reciprocal, epsilon naught is equal to what? 1 by K unit. So that is equal to 1 by Newton meter square per Coulomb square. Set it up. So Coulomb square by Newton meter square. That's it. So Coulomb square by Newton meter square. Clear everyone? Yes or no? Clear everyone? Hello Bacho, clear everyone? No doubt. Good. Good. Next. Now here from this, what do you say, Coulomb's law, what kind of question Kcet ask or Comedk ask? They ask about the inverse square rule. They ask about inverse square rule. What they'll ask? They'll say, if the radius is increased 2 times, how much will be the force? Earlier the radius was R, suddenly they made it double. Now what is the change in force? This kind of questions always is preferable in CT. Clear? Huh? So if radius decreases, inverse means what? If one decreases, the other increases. If radius decreases, force will increase. Clear? So that is known as inverse square rule. Inverse means opposite dependence. If one increase, other decrease. Clear? So if radius is doubled, force will become what? 1/4. Clear? So there you have to be fast. Clear? Now, so they'll give you sometimes like this kind of question. Radius doubled, force will have what? Force is what do you say? Tripled. What will be the radius part? So you need to know these questions very faster. Okay. Earlier two charges were just separated by a distance of 2d. Now they're separated by a distance of 4d. So what is the ratio of the force F1 by F2? So this kind of question CT asks. Okay. So you have to be very clear for that. Okay. Clear everyone? Very simple, very easy. Clearer? Yes, no, no doubt. This page done. And how do we draw a graph? A lot of people, they don't know how to draw a graph. Come on, draw a graph and show me. How do you draw a graph between force and radius? Force and radius, how do you show it? A lot of people, they don't know. So don't be scared of graphs. Graphs are the various easy things. The most easy thing, and it helps you a lot. Okay. So how do we draw a graph between force and radius? So very simple. What do you do? Force is here, radius is here. So if one is increased, the other will be decreased. Done. And if one decreases, the other increases. So like this. So you can see if I'm increasing R, my force is decreasing. And if I'm increasing the force, my radius is decreasing. Clear? Clear everyone? See, this is the middle point where both are like, let's say 1, 1. So here if you increase the radius, what will happen? The force will decrease. It will keep on decreasing this side. And if you increase the force, this radius part will keep decreasing. Clear? Yes or no everybody? Karthik, Vimal, Vinayak is not there. Where is the Vinayak kid? Doubt, no doubt, clear? Chemistry analysis, maths. We have done both maths analysis, chemistry analysis also. Okay, chemistry I haven't put up till now, but maths analysis video is already there. You can watch it, Aditya. Okay. Maths analysis video is already there. You can watch it. I'll just put the link down again. Okay. Or you can download the app SAMCLASSES. There also it will be there. Clear everyone? We'll move to the next page. Okay. Now validity of Coulomb's law. Where Coulomb's law is valid. Okay. I'll send the video link soon. Don't worry. Before the class gets over, I'll send you the video link. For maths also is there. Now, where is Coulomb's law valid? So first, Coulomb's law is for extended charge, a very big charge like this is invalid. We can't use it here. In these cases, we can't use it. But for a point charge, yes, definitely. Okay. Two charges at rest, we can use it. Now, if two charges in its motion, we can't. Because the moment charge move, they'll create field. Magnet part will come, current part will come. So that is different case. So we'll go and learn that in the chapter 3rd and 4th. When a charge slowly starts running. Okay. So then we'll talk about current electricity, not static. Clear? One rest, one motion we can do. One rest, one motion we can talk about. Coulomb's law will be there. Okay? Clear everyone? Where? Both moving, we don't take. Both moving, we don't take. One rest, one moving, we take it. And then for extended large body charges, then no, we don't. Small point body, point charge, yes. Clear everyone? This page? Yes, no? Okay. Clear? Let's see the next page. Anybody having any doubt, never hesitate to ask the question. Never ever hesitate to ask the question, okay? Doesn't think that here we are, if you'll ask the question, you'll be like, here we are not here to show off. We are here to learn, okay? Now let's see. We'll be talking about what does this epsilon means, okay? A lot we said epsilon means this, that. Now we'll be talking about the terms, the actual meaning of epsilon, okay? So let's see. Epsilon means, in literal word sense, permittivity of free space. But what do you mean by that? Permittivity of free space. But sir, again you said epsilon, one complicated word. Again you said permittivity of free space. Again one complex word. What actually does it mean? Correct. So let's see. Now, F is equal to K, Q1, Q2 by R square. We know this is Coulomb's law. K depends on the medium and K is inversely proportional to epsilon. Okay, this much we know. Then what is this epsilon? So let's read first the definition of epsilon. The capacity of vacuum to permit electric field, okay, the property of free space which allows its own field to decrease the interaction between the charges. Did we understand anything? Did we understand? Illa. We don't understand. But one thing we know, that force and epsilon naught, they're not what? Friend. They're enemy. Can we say force and epsilon naught is enemy? Because see, force is inversely proportional to epsilon naught. Correct. So epsilon naught is the body who is there to disturb the force. So epsilon naught is what? It is an entity, it is a person who is there to disturb the force body. So let's say understand a small story. Okay. So two friends are there. Okay. Friend 1, friend 2. They're very good friend. Okay. Two friends are there. They're very good friend. Now a third friend is coming, epsilon naught. These two friends are casually talking. Okay. And this third friend is coming and they're disturbing both of them. Clear? So this body is nothing but epsilon naught. Clear? And this F1 and F2 is nothing but the charge. And between them, what is the torque is going on? That is the force. Electrostatic or Coulomb's force. Clear? And epsilon is the entity that disturbs that force. Clear? Yes, Heath, sir. Epsilon naught work as the barrier to oppose the force. Correct. So here epsilon body is nothing but it is the person or a barrier which is opposing the force between them. So it is just disturbing them. Like you two people are sitting in a CCD, cafe coffee day, okay, and having the without having the coffee, they are just sitting. So what will happen? The waiter will come, like, sir, you need to order something to sit here and talk. Correct. So he'll keep what is say coming till you guys order something, okay? Unless and until you order, it will be disturbing, correct? So same thing like that. So epsilon is the entity that disturbs the force between them. Clear, everyone? Yes, no, didn't get it, anything, do tell me in the chat section. Till here, clear? Come on, yes, no, no doubt or doubt. You can write ND or D. If you have doubt, put a D. If you don't have a doubt, put ND. I'll wait. It's a good concept. Uh, I'll again explain if you want. No issues in that. Very simple. Okay. It's just simple. Remember the story that your friend are sitting in cafe coffee day and your buddy, you are charge 1 and your friend is charge 2 and the waiter is epsilon. Until unless you order, he'll keep on poking you. So what happens? Epsilon is the barrier. Okay. So it always comes and disturbs. The more strong the epsilon, the more it will disturb. Clear? So epsilon naught is minimum where? In vacuum. So that's why the force in the vacuum part is maximum. So epsilon value is minimum in vacuum. So that's why the force is maximum in vacuum. Clear? Because there is no field to disturb between them. Two charges are there, there is no field to disturb between them. There's no nothing in between. In vacuum case, there's nothing to disturb. So that's why epsilon naught is minimum here. And force is what? Maximum. Clear, everyone? Yes or no? Okay. We'll move on to the next page, students. Very simple. What about the dimension? I already told you we can do the dimension formula. Important. Everybody do write down in your notebook. For CT part, again one question came from the dimension. So do write it down. Do write down the dimension formula. 1 second, students, just. Clear, huh? Everybody got it? Okay, good. Now let's come to the next page. Now we got force in vacuum is maximum. So what about force in any other medium? So that is equal to 1 by 4 pi epsilon. Now the epsilon changed, correct? In vacuum it is the smallest, so that is epsilon naught. In other place it is epsilon. Epsilon into q1 q2 by r square. Clear? And for vacuum it is this one. And we already know vacuum it is the least. So epsilon is greater than epsilon naught, correct? Always, because the vacuum body is what? The least stronger, and for any other medium other than vacuum they are very strong. Clear? So they can ask you a question this also. Clear? That the permittivity of free space of a medium, they'll frame the question like this. Listen very carefully. The permittivity of the free space of a medium is more than the permittivity of the free space of a vacuum. Yes or no? True or false? Okay? Is it correct? Not correct. So you already know in vacuum it has the least power. Any other medium it will have more power. So epsilon will always be greater than epsilon naught. Clear? Clear everyone? Yes, no, yes, no. Any doubt, put it in the chat section. No issues, I'll again explain if it is a bit heavy also. If it went bouncer, do tell it, okay? So basically epsilon is the property to disturb the force. In medium it disturbs more stronger. And in vacuum, since no material is there, no medium is there, so it disturbs very least. Clear? Doubt, not doubt, clear? Do confirm it. Yes and no, yes and no. Okay, clear. Now one more term comes. Relative permittivity. What is relative? Whenever we measure something with respect to what? Vacuum. So whenever we check how strong you are disturbing, the material is disturbing with respect to vacuum, whenever we find that ratio, that is epsilon r. That is relative permittivity. Means with respect to vacuum, how strong it is. Correct? Like let's say in vacuum, the material is disturbing by 1 time, like 1 unit. And if I talk about a material like glass, it is disturbing 10 times of epsilon naught. So this part, how strong it is towards the, in terms of vacuum, we talk about epsilon r. So epsilon r is nothing but relative permittivity, where we talk about how strong it is with respect to vacuum. Clear everyone? So epsilon r is nothing but epsilon m, means relative permittivity of medium by relative permittivity of free space. Clear or vacuum? Clear everyone? Just a ratio. You don't have to put up so much of brain in that. Nothing question comes like that. Okay. When we'll be solving the PYQs, you'll see all questions are like chindi. Okay. It will be solved like this. So don't worry. Okay. Clear everyone? Yes. Okay. Now, so just now we got, what would we got? We got epsilon r is equal to epsilon m by epsilon naught. If somebody says, sir, find out epsilon m, very simple, send epsilon naught, that's it. Epsilon naught into epsilon r, that's it. No difficulty. Clear? So epsilon r is nothing but epsilon x. One simple example is there. They have given that the relative permittivity of a medium is 100. Relative permittivity is 100. It means that the medium is disturbing 100 times more than vacuum. If they say the relative permittivity of a medium is 100, it means that if vacuum I am disturbing you 1 time, in any other medium I will be disturbing in what? 100 times more than that. Clear? Which video you are looking for, Aditya? Maths analysis video. I'll put the link. I'll put the link. In app, if you go to the content side, you'll get it. In the batch, you'll be getting it. The recorded sessions and everything, live sessions, it will be recorded form. It will be there. Okay. Now, next, this part important. So, epsilon r tells us how much strong it is with respect to vacuum. Clear? This part, student, keep it in mind. I'll explain you later. The electric field inside a conductor is 0. We'll come to that. Why it is will come. Okay. A bit in the next. Analysis video. I'll share the link. Don't worry. I'll share the link. 1 second. Just give me 1 second. Maths. I'll share the maths link also, don't worry. Where is the video link? In this you will get it, okay? Now, next. For a conductor, students, very important for a conductor, it doesn't disturb, it's infinite, okay? It allows everything. Air and vacuum 1, and for any other medium, it's greater than 1. Clear? Epsilon r value for these three things I've just given, okay? Keep it in mind, okay? It's important also. Do write it down, okay? Now, let's see the next page. Next is principle of superposition. Principle of superposition. Now, what does the principle of superposition say? It says that we have two charges, Q1 and Q2. So, for two charges were there, we are easily able to find the force. What if multiple charges come up? Instead of just 1, 2 charge, they like charge 1, charge 2, charge 3, charge 4 and charge 5. In that case, how will you find the total force? Then principle of superposition comes. So what does it say? It says that net force on any single charge you take, net force on any of the charge is equal to vector sum of all the force acting on the charge. That's it. Means if I want to find the charge on this force Q1, so first I'll find what is the force due to Q2. I'll add it vectorly, okay? I'll add it with the force due to Q3. Again, I'll add it with the force due to Q4. And again, I'll add it with due to the force due to Q5. So F net is equal to nothing but F12, force on charge 1 due to second, plus F13, force on charge 1 due to third, plus F14, force on charge 1 due to fourth, plus F15, force on charge 1 due to fifth. Clear, everyone? Clear? So what did the principle of superposition say? It is, in reality what happens, not one charges will be interacting with one, multiple charges will come. So how do you find the net force? You do vector sum. Individually first find due to first what is happening, plus vector sum of with the second, with the third, with the fourth, with the fifth, with the sixth. Whenever we say vector sum, we take the directions also. Clear? Everybody got it? Yes, no, yes, no. Doubt, no doubt, lot of doubts. Do tell it. A small request to all of you, do share the link of the channel to all of your friends so that they are able to know and we are able to help as many as students possible, okay? For 1 month, we are providing the crash course also. We'll be talking that in details later. Now, till here, everybody got it? Yes, no, any doubt, students? If no doubt, do put it in the chat section. If you have doubt, put it in the chat section. Okay. So principle of superposition is done. What does it says? You should know that much. Bas, that's it. Because we have less time, we can't go too much in depth. Next, what we have? Electric fields. Now, what is electric field? Now, what happened is, we have a charge here and we brought another charge here. This was positive charge, this was also positive charge. So what happened? It started to get repelled. Correct? So what will happen? So we know that, or you can take one single charge and the moment you try to enter another charge here, this charge slowly starts disturbing it. If it is same, both are of same nature, what will happen? Then it will try to attract. And if it is of different nature, it will try to, sorry. If both are of same nature, then it will repel. Correct. If both positive, it will repel. If both negative, one positive, one negative, it will attract. Clear? So what do we understand by that? It means that even though the charge is here, till here also I can feel that its presence is there. So the space around the charge in which its effect can be felt is known as electric field. What is electric field? The space around a charge in which its force can be felt. Clear? Got it, everyone? Now, electric field is equal to what? Force by charge. Now, in order to measure the electric field, we bring a unit charge. Now, why do we bring a unit charge, students? Anybody? Anybody who can tell me the answer? Anybody? What about Vimal? To measure the charge. Now, let's say if a charge is plus Q here and we bring a bigger charge Q. We can also measure, no? Why are we not bringing a bigger charge? Why are we bringing a small test charge? What will happen is, if we'll bring a bigger charge, very correct, what will happen? This force is very much strong. So what will happen? We won't be able to measure the force of this. This will proceed. Okay. So in that case, it will be very difficult. So that's why what we do, we bring a unit positive test charge. We need to bring a unit positive test charge. Clear, everyone? No, we don't bring a neutral. Neutral will be no effect, no. Okay. So we bring a unit positive test charge. Okay. The test charge is always a unit positive small charge, 1 coulomb, that's it. Okay. So now we'll come to this. It has a huge application also. Okay. Now what happens is, when we say the electric field lines for a plus charge, we say, let's say a question came in CET, the electric field lines for a positive charge is radially outward. Why? Electric field lines for a positive charge is radially outward. Why? Let's see who all can answer. Come on, let's see. Take 1 minute of time. It's a good question. Just now what we have explained from there only. Okay. The basic definition of electric field is just this part. If you read, space around a charge in which another charge like test charge experience a force. So means electric field is nothing but space around a charge in which if we bring another test charge, how we feel it, that is given by electric field. Now, why the electric field lines for a positive charge is radially outward? Anybody who can frame this answer? See, we know this by definition that say yes, whenever they'll say a positive charge, will make it lines outward. Why it is outward? Come on, let's see who has the thinking capability. Think, right, wrong, put up the answer. Doesn't matter. Physics is all about thinking. Very good, very good. Nothing related to energy like that, we can say. But simple terms is, see, basically we test the field or electric field by throwing a test charge. So when I'm sending a test charge to this, what will happen? It will come for a positive charge. It will what? Thrown out. It will repel. So that's why radially outward. Same thing for a negative charge. What will happen? I'll put a test charge. This negative charge will bring what? It will be attracted. It will try to bring it closer. So for a negative, it is what? Radially inward. That's it. Because here by definition we define it with the help of a test charge. So whenever we bring a test charge in terms of whenever we bring a test charge, what will happen? This will always push it outward. It will always apply a outward force. That's it. Clear? Welcome to that of the properties of electric fields. Welcome, Nishat ma'am. So here we're just talking about, in this case, that very good, it repels each other. That's why, because we are bringing a positive charge, and the definition said is we always test the electric field lines we define by testing with a unit positive charge. So when we are sending a unit positive charge, since this is also positive, so what it will do? It will repel each other. So that's why it will apply a outward, radially outward force. Clear? So in the outward direction. Clear? Got it, everybody? Everybody got it? Any doubt? Yes and no? Any doubt, anybody? Okay, good. Let's see the next part. So why now we know for a negative charge it will be radially inward. Okay, done. Now what are the formulas that we need to take care? First, electric field is equal to what? Force by charge, very simple formula. And that too, that's why we say charge limiting tends to 0, means very small charge. Clear? Charge tending to 0, that's why they use the limit. Okay, don't get confused. Physics chapter wise, it is for maths also. Okay, I'll share it in case it will be there. I just need to check after the video. Aditya, I'll send it, don't worry. Okay, after the session I'll send it. If you watch it whole, I think so the comparison is there between maths and Comedk, this part inside. Okay, so I'll share it, don't worry. I need to check. We have already done for the maths also. I'll send it. Okay. Now next. Now just now ma'am said, Nishat ma'am, like electric field is what? Vector quantity. Correct. It has both magnitude and direction. And how else we know? Electric field is equal to what? Force by charge. Force is vector, this is scalar. So again vector quantity, clear? What is the unit? Newton per coulomb, we can get it from here. Or V by M, we'll also see this formula also. E is equal to dV by dr, so we'll come to that formula. But as of now, E is equal to V by Q. Electric field is equal to force by charge. Clear everyone? Clear everyone? Yes or no? Yes or no? Got this part till here? While limit Q tends to 0 everything, vector quantity. Got it everyone? Okay. Going to the next page. If anybody has any doubt, do tell me, okay? Now, next, for CBSE kids and for the PU syllabus, you have this derivation. E is equal to V by D. E is equal to potential gradient, voltage by length. So that again we'll do later in details in the capacitor chapter. Don't worry, potential and capacitor. So from there we got the unit, V for voltage and M for distance for meter. So V by M. Clear everyone? Very simple. So we know electric field is equal to force by charge. Electric field force charge formula is what? Q by R square, and charge is what? Q. So 1Q got cancelled. So electric field formula what we got? K capital Q by R square, done. Here also inverse square law, electric field and R square, they are inversely proportional. Clear? If one increases, the other decreases. If one increases, the other decreases. Clear everyone? Now in this also, for finding the electric field for a lot of charges, 1 charge, 2 charge, 3 charge, 4 charge, we can use superposition principles. We can use superposition principle. Just like force, what we were doing? Force on charge 1 due to others is equal to what? F12 plus F13 plus F14, like that. So here also electric field due to the first charge, electric field due to the second charge, electric field due to the third charge, electric field due to the fourth charge. We can easily do same thing. Clear everyone? So we got the formula of electric field. Electric field is equal to what? Force by charge. What is the force formula? K capital Q means 1 charge 1, charge 2 small q by R square, and then divide by this another charge. Cancel these two charge, you'll get this formula. Clear? Everybody clear in this? Any doubt? Any difficulty? Do tell me. Clear everyone? Okay, let's see the next part. Electric field lines. Now what are these electric field lines? Okay, now electric field lines are basically imaginary, straight or curved lines, okay, in which if I draw the tangent, it gives the direction of electric field. What is the definition? Imaginary, straight, it can be curved also, in which if I draw a tangent here, it will give me the direction of electric fields. It will give me the direction of electric field. Clear? What is the definition of electric field lines? It is imaginary, means we can't see it. It doesn't exist. But we are thinking that it's like that. Okay? It can be straight. It can be curved. But if I draw a tangent on that lines, I'll get the direction of electric field. So this is the property. Clear everyone? Clear everyone? Okay. Now what are the other properties? It starts on the positive, because we see in positive what will happen? Electric field lines, they went outward, and it ends in the negative. And in the negative what happens? It goes inside. Clear? Two field lines never intersect. This question have been asked in the CBSE, in the PU, and in the CT also a lot of times. Why? Because if they intersect like this also and this also, so at one point tangent will be like this, tangent will be like this. We'll have two electric field direction. Not possible. Correct? At one point we'll have two electric field lines. The direction of electric field lines will be two sides. It can't be possible. It can be only in one part. Correct. So two electric field lines never intersect, because if they do, then at one point we'll have two direction of electric field, which is not possible. Clear, everyone? Next, electric field lines do not have any breaks. They don't have any breaks. It is continuous. Okay, it can't be like suddenly it is going, suddenly one gap is there and again it started. No. Clear? It is always continuous. Clear, everyone? So this chapter holds a good weightage, a minimum of 3, okay, and can go till 5. So very important. And the questions which you'll see in CT and Comedk both are very simple. Nothing is there much. One or two concepts are there. If you do 30 seconds, all questions we can solve it. Okay, 30 seconds. That's it. Clear, everyone? Now, experimental questions came very rare, but that also will do. Don't worry. Okay, mixed questions like where from electric we are going for magnetic, that will take after chapter 4th. Okay, the questions where all the other concepts are mixed, very rare it comes, but some one or twice it has came, like in last 7 years max 1 or 2 questions you will see. So that will be taking after 4 chapters done. So you will know what properties of magnetic also is there. Okay. Clear, Vimal? Okay. Let's go for the next page. Any doubt till here? Any student? Any doubt? Any doubt? Electric field lines till here? Everybody clear? Tomorrow class sharp 10. Okay, be there. Maths will be doing few more questions from det, and then physics will complete this chapter. Okay, next. Electric flux. What is this flux? It's nothing but field lines, number of field lines means how many field lines are going perpendicular to a surface. Let's say this is my surface. Okay, this something is there, like let's say a book or something. How many field lines are passing? How many field lines are passing which are perpendicular to it? So if 10 field lines, so that is the flux. If they are passing parallel, we don't count it. If they're passing parallel, we don't. That is not flux, students. Okay, that is not flux. Okay, what we count? The perpendicular ones. The perpendicular ones, not the parallel. Very important. What they'll do? They'll give you a question like this. Okay, they'll say field lines which are passing like this, perpendicular is 20, and which are passing like this is 5. What is the flux? 5. Find it out. So lot of people, they'll do mistake in this. Very simple, but they haven't read the or understood the definition only. Clear? So what will they do? They'll write the answer 5, or somebody will subtract and write. Clear? Somebody will add and write. So they'll put options like that also. 20, 5, 25, 15. Clear? So we have to be a bit what? Sharp also and clever, not to commit these kinds of mistakes. Correct. 20. So what is the definition? Field lines perpendicular to the surface. Number of field lines perpendicular to the surface. That's why I've kept in the concept video all the derivations or all the definition very crisp. Whatever is needed, that's exactly, no stories. Okay, less time, like this only will finish. Clear, everyone? Chalo, let's erase it. By the way, whoever wrote Manipal exam, how's the exam? Who all wrote Manipal exam today and how was the exam? Good, bad, okayish. Okay, nothing good, bad. Okay, let's see the next one. Next, what we have is dipole. Very important, very simple. Okay, what is a dipole? Equal and opposite charge. So first condition, they have to be equal and they have to be opposite. So if I have taken a charge plus q here, so I'll take a charge minus q. So first equal, the magnitude wise they are both equal and they're opposite. One is positive, one is negative. Very simple. Separated by a distance of 2a or a small distance. Here that small distance I'm representing by 2a. Separated by a distance of 2a. That's it. Clear? Very simple definition of dipole. What is it? Equal, opposite, charge separated by small distance. Clear everyone? Okay. Now, so here I have shown odd 2L also we'll see a lot of places written. Okay. Now, next is direction of dipole. Very important. Keep that in mind. A lot of students they forget. Direction of dipole, mark it important. Negative to positive, negative to positive, negative to positive. Correct? Direction of the dipole is important, students. Negative to positive. Clear, huh? Negative to positive. Okay. Clear everyone? Negative to positive. Direction negative to positive. Chalo. Dipole moment is what? Vector quantity. It gives us strength of dipole. How much is the strength of the dipole? That is given by another word known as dipole moment. Dipole moment describes the how strong the dipole is. Clear? Nothing more than that. So whenever somebody says dipole moment is this, means it tells the strength of the dipole. Clear everyone? So dipole moment is any of the charge, okay, magnitude of any of the one of the charge into the distance between them. So product of the either charge means any of the charge and the distance between them. Clear? What is the dipole moment formula? Either charge, any of the charge and the distance between them. Clear everyone? Clear everyone? Next. So this page clear, any doubt? This page clear, any doubt? Clear. What about others? Only I'm seeing the response from Karthik. Okay, Nishat wrote. Karthike and what do you say? Vimal sir, if a charge is placed at a distance r, we'll come to all that questions, Vimal. Don't worry. All that questions will be taken in PYQ. Very simple. Okay. You have taken a cube, you are placing at one of the edges. Either you are placing here, you are placing here, okay, or you are placing at inside center or at the face centered. Everywhere will do. Don't worry. Okay. Till here, any doubt? Will come all questions. Once the chapter is complete, once the PYQs is complete, you come up with any question, we'll solve. We'll see. By the time you'll be like, sir, all question done. No problem. Okay. Clear? Everybody clear till here? Okay. Next. Now, one more thing, students. Since we have very less time, we can't go in the derivations. We can't go deep into the derivations, explaining and proving the derivations. Okay. Though it is there, but I think so you all know from the physics point of view. For the CBSE, yes, you need it. For PU, need it. But we are not doing CBSE or PU. We are doing the CET crash. So in this, we can't derive anything. Okay. So we don't need the derivation part. Derivation, I think so you can do it on your own. Hi Yelaguresh. Okay, so derivation part you can do it on your own. If still anybody has difficulty, when we'll be taking the doubt session, I'll clear that also. Clear everyone? Because derivations are also very simple, but it will take a lot of time. In CT we have less time. We'll focus more on concepts and then questions, done. Okay. Now, till now what we did is we talked about the dipole. We know about the dipole moment. Dipole direction was important. Direction was negative to positive. Always remember. Dipole moment means gives me how strong the dipole is. Clear? Now we'll be talking about electric field due to a dipole. When you have a dipole, what will be the electric field of that? Clear? So our target is to know about that. So where it can have the electric field, how strong it is, we'll talk about that. Okay. Let's see. So we have taken two charges. We have taken the dipole, one negative charge, one positive charge for a dipole, separated by a distance of what? 2L. Separated by a distance of what? 2L. So this here to here the distance is L. Here to here the distance is L. Now somewhere here on the axial line, what is the axial line? A lot of people, they're not clear about axial line also. When we talk about axial and equatorial, this is what is axial, what is equatorial? Understand, axial means line which is lying on the axis. This is the axis joining the two centers of the charge. So any point which is lying on this line is known as axial point. Okay, clear? Or axial position. Clear everyone? Two charges are there. If I join these two centers, student, okay, and if I make a line, any point which is lying on this joining line is known as axial point. Clear? Or points lying on the axis joining these two charges. Clear everyone? Yes, no, any doubt, anybody? Tell this part. Come on, come on. Any doubts? Be clear, never hesitate to ask your doubts, okay? Any simple, strong, good, bad, doesn't matter in doubts, okay? Now let's see. So what will happen? This charge. Now if I want to find the electric field here, again what we'll do? Same thing. We'll bring a small unit positive charge. See, people in the olden days, they were very fascinated with positive charge. So wherever they used to do something, they will take positive charge only. Okay. So here, they have taken a positive charge, but this is also positive. So what it will do? This positive charge will push it like this side. Correct? So electric field will be what? Towards this side, due to this positive charge. But the negative will what? Attract it towards itself, because this is negative and this is what? Small positive. So due to the negative charge, electric field will be this side. Clear? So positive is pushing that side and negative is pushing this side. Clear? So net electric field again will apply which formula? Superposition. Net electric field will be what? Electric field due to positive plus electric field due to negative. Now here, so what will happen? Now they are opposite. One is in this direction, one is in this direction. So what will happen? A minus will happen. If they were both in same direction, a plus will be there. Hi Shinder, you got late today, so many days, all okay? So what will happen? Now, do you remember the electric field formula? Electric field formula was what? Charge by 4 pi epsilon naught. What was the electric field formula? Electric field formula is what? Force by charge. So that is equal to kq by r square. Clear? So I've just taken so electric field due to this plus charge will be what? 1 by 4 pi epsilon naught. I can write k also. Q by. Now what is the distance? So distance will measure from here. So here to here, how much distance, student? Here to here, total from the center is r. This part is L. So here to here is what? R minus L. Clear? Very simple. So it will be electric field due to plus Q charge. 1 second. So electric field due to this plus charge will be 1 by 4 pi epsilon naught, this charge Q, by the distance. So distance from where we'll take? From this center to this point. So here to here is L, total is R, and here to here is L. So this part will be how much, student? R minus L. So that's why R minus L whole square. Clear? Now, due to negative charge, again 1 by 4 pi epsilon naught charge by R plus L. From here to here is what? L, and here to here is R. So R plus L. Now we'll apply here. Okay. What is the common here? Charge Q was common and 4 pi epsilon naught was common. Just take it out. Done. Now what formula will apply here? We'll just do the LCM. Once we do the LCM, student, what we'll get? We'll get this. Clear? Anybody has doubt how we got the denominator? Anybody has doubt in the denominator, how we are getting the denominator? Do tell me, otherwise I'll show. Otherwise I'll skip. If you have doubt, then I'll show. If not, if you know already the derivations, then I'll skip. Yes, no, put it in the chat section. If you have doubt, I'll show, students. Come on, come on, come on, fast, students. Anybody has any doubt? How did we get this denominator? So, or you already know it? If you already know, well and good. You have a doubt, Yellow Guresh? If you don't have doubt, type ND. Okay? If you don't have doubt, type ND. Karthikeyan, no doubt. What about Yellow Guresh? You have a doubt? You don't have a doubt? It's just we have taken the LCM, but I'll show, no issues. What about others? Nishat, Vimal, Heat. Doubt, no doubt, doubt, no doubt. Come on, come on. Electric field due to negative charge R plus L, how? Okay. So Yellow Guresh has a doubt. Electric field due to the negative charges R plus L, how? Okay, see here. We'll just take this space. Okay. See, this is my negative charge and this is my positive charge. Here to here, this distance is L da, this distance is L. Total is 2L. Now somewhere here I want to find due to this Q naught. Okay. And from here to here it is R. From this center O to here is R. Now from this charge, if I want to find, what will be? This total is, student, this total is Yellow Guresh R. And if I subtract L, what I'll get here? This part R minus L. And this part is L. And if I add this part, whole R, so from here to here will be what? R plus L. Yes or no? Check it, Yellow Guresh. Got it? See, distance always when we are measuring will take from one charge to this charge. So how much is this? This total is what? 2L. And this one is what? Or you can say this one is R and this one is L. So L plus R or R plus L. And this part, if you see, this total is R, this part is L. I just need this part. Correct. So it will be R minus L. Clear? Got it? If you still have doubt after the class, again I'll explain, okay? Don't worry. Clear? Keeping the doubt, you should not go, okay? Now, let's see. So this I've just taken the LCM. I've just taken the LCM, R minus L square into R plus L square. So we already know A minus B into A plus B is what? A square minus B square. So same way we got this one. Clear? Okay. Yellow Guresh, is your doubt clarified? Not clarified? Do inform. If not, later after the class also I'll clarify, okay? Now, so if I solve it, electric field, net electric field, what I'll get will be Q by 4 pi epsilon naught. From here we'll get 4 LR by R square minus L square power whole square. Clear? Now, Just now I showed you P is equal to what? Charge into twice the length. So this part, charge into 2 times of L, we'll put it as P. So what you'll get? 2PR by 4 pi epsilon naught into R square minus L square. Clear? Or one more square is there. Okay, one second. Clear? Now, if the dipole is very short, dipole very short means the radius is very big. So if R is much bigger than L, if R is much bigger than L, then what will happen? We can skip this L. Okay, L is small, L square will be more small. So we can skip this L. So what we'll get? We'll get this as 2PR by 4 pi epsilon naught R power 4. 1 R and 1 R here will be cancelled. We'll get this formula. This is for short dipole. This is for short dipole. Clear, everyone? In this case of the dipole, okay, see the direction of electric field also and the direction of dipole moment, both are in same direction. This question also Kcet has asked so many times. The direction of electric field and the dipole moment. What is the direction? Is it 0 degree, 180 degree, 90 degree or 45? 0 degree, same direction. Clear? Got it, everybody? Clear? Till here, anybody has any doubt? So these two are the formulas, we need to keep that in mind. These two are the formulas, we need to keep that in our mind, okay? Any doubt till here? Got it. Okay, good. Now let's see we'll go for the next part, or you want to keep it till here? Vimal just asked on the right moment. Well, what do you say? Keep the class till here for today, or we will extend? What do you say? How much energy you all have? Keep it till here or end it or extend it? What do you say, students? Come on, fast. Okay, for today we'll keep it till here only, okay? So everybody work hard, revise each and everything. See you have any doubt, I'll again explain, okay? You all can go. For those who have doubt, they can stay. For those who have doubt, they stay. Rest, you all go. Yellow Grace, you have doubt still in that part. I'll show it. For those who have doubt, you stay. For those who don't have, you can go. We'll end the class now. Okay. Thank you, Kartikeya. Thank you, Divya. Okay. So for those having the doubt, Yellow Grace, you have the doubt. Next. So for today we are keeping, okay. For today we are keeping it till here, okay. Questions practice and all we'll do tomorrow. We'll finish the chapter tomorrow, okay. And we'll take all the PYQs, don't worry. By 30 days we'll complete each and everything, okay. Not much is left. Equatorial point, okay, the relation, dipole, work done, Gauss law, and applications. Done. That's it. So we'll continue and complete tomorrow. For today, we'll keep it, okay? Because a lot of people, they have written Manipal and other exams also, okay? So for today, let's keep it till here. Tomorrow, sharp 10. Basha, you came late. What happened today? No doubt, Yellow Ganesh. Good. So everybody is telling continue the class. Will we finish it? Yeah, recording will be there. Tomorrow, see, tomorrow's class timing will be 10 a.m. sharp. Everybody be there 10 a.m. Okay, don't be delayed. Clear? Tomorrow timing 10 a.m. Okay. Okay, no. Everybody download the app. SAM classes notification will come. Don't worry, Basha. By tomorrow, we'll fix the timings. Okay, so that none of the students they miss the what do you say class live sessions. Okay. So we'll keep for today till here only, and tomorrow sharp 10 everybody be there. Clear? Can everybody be there by sharp 10? Inform all your friends also. Tomorrow math and det will be doing questions, and then physics will complete. Tomorrow we'll do two things together. Physics will complete. Okay, and I'll put up Aditya, don't worry. Do ping me in the WhatsApp number also, 8050491740. Okay, here I'll send you whatever the details you need. Okay, don't worry. This is the contact number, you can call anytime, any doubt. Okay, tomorrow math and det PYQ will be solving a bit more, and then this chapter will complete and we'll do the PYQs Okay. Tomorrow YouTube only, okay? Now, properties, which one properties you want me to explain by, what you say, Yellow Grayish, this one? Yeah, YouTube only. Electric field lines, the properties are very simple. First, the definition is important. What is the definition? Very crisp and simple. Imaginary means they doesn't exist reality, okay? Imaginary first. Straight, it can be, or it can be curved. So it can be both, but it should have one unique property, that is that if I draw a tangent, if I put a tangent here, it should give me the direction of electric field. So what is the definition? Imaginary, straight or curved line, but if I draw a tangent on that line, I'll get the direction of electric field. So this is the definition, okay? Good night, Basha. What are the properties? We know that it starts from the positive, it starts from a positive charge and ends on a negative. Starts from a positive, ends on a negative. Very simple. We've already explained why also. Okay. Two lines never intersect. What will happen if two lines they intersect? No. What will happen? At this one point, one tangent will be like this, another tangent will be like this. So can it ever be possible that at one point we're having one electric field direction as this one electric field direction as this one? So not possible. At one particular point, we can't have two different directions. Clear? Tomorrow I'll show and again I'll revise the blueprint also. Don't worry. Nisha, don't worry. Tomorrow maths part I'll again revise the blueprints also. Electric field lines do not have any breaks. Always continuous. Electric field lines do not have any breaks. Okay. So maths tomorrow I'll tell you which way we are going. I'll make you write also for all the students. Okay. Clear? Now sessions are all recorded, so don't worry. Now, so we'll keep it till here, students, okay? So for today till here, tomorrow be there sharp 10, okay? Don't delay. So good night everyone and thank you for the class. Tomorrow be there sharp 10 a.m, okay? Thank you everyone. See you tomorrow. Good night, everyone.